Question number 6. The 33 students' names from Form 5 are placed in a hat. 4 names are drawn, one after the other. Each person whose name is drawn wins a Ben & Jerry's ice cream cone. The names are not put back into the hat, so the same person can't win more than once. How many ways can 3 names be drawn? Because the person who wins first gets the same prize as the person who wins second, or the person who wins third, or the person who wins fourth, the order does not matter. So the order is not important. That makes this a combination. And because we're not putting the names back in, it's a combination without replacement. We could use our formula, which is n factorial over r factorial, all divided by n minus r in brackets factorial. Our n is our 33. Our r is how many people we're taking is 4. So 33 factorial divided by 4 factorial times 29 factorial. I had a few people get this wrong. They had this part right, but they didn't do the work in the calculator correctly. There's 2 ways of doing this. You could do 33 factorial divided by 4 factorial, but don't press times 29 factorial because it's 33 factorial divided by 4 factorial and also being divided by 29 factorial. So do divided by 29 factorial, and that gives us 40,920. Now this 19.9 repeating is error in the calculator. Shouldn't happen on your handheld calculators. We end up getting the other way of doing it on the calculator, 33 factorial divided by, and then in brackets, 4 factorial times the 29 factorial. Close the brackets. Okay, we get the same answer. The other way of thinking about this is we could say, if you didn't want to use your formula, you could do it logically. 33 people for first, 32 times 32 choices for second, right? I have taken one person out of the hat. We have 32 left, times 31 for third, times 30 for fourth. Because the order doesn't matter. Remember the example where we had 3 people? We had A, B, C, A, C, B, BAC, BCA, CAB, CBA. So that would be a permutation. And we got these 3 people arranged 6 different ways. But because the order doesn't matter, we want to turn those 6 into 1. So how do you turn 6 into 1? Divide by 6. So divide by 3 factorial, which is 6. So in this case, we have 4 people, right? We don't care about the order of them. So we're going to divide by 4 factorial. Either way, you're going to get this number. 6b, how many ways could the names be drawn if the names were put back into the hat after each drawing? So we're talking about a combination with replacement, which is that squirrely one. So we're going to do the n plus r minus 1 in brackets factorial divided by r factorial divided by n minus 1 close bracket factorial. So that's going to give us 33 plus 4 is 37. Take away 1 is 36 factorial divided by 4 factorial. And then 33, take away 1 is 32 factorial. On our calculator, 36 factorial divided by, open bracket, 4 factorial times 32 factorial, close the bracket, equals 58,905, like that. 6c, the next day, the 33 students' names from Form 5 are once again placed into a hat. This time only 3 names are drawn, one after the other. The first person drawn gets to be principal for the day. The second name drawn is vice principal for the day. The third chosen is lowly math teacher for the day. How many ways are there to pick the 3 students? Because order matters, because the first place is principal, the second place is vice principal, third place is math teacher. The order is important. We're talking about a permutation. We're not replacing the names after each drawn, so it's a permutation without replacement. N factorial over n minus r in brackets, factorial. That's 33 factorial out of 33, take away 3 is 30 out of 30 factorial. Handy dandy calculator time. 33 factorial divided by 30 factorial is 32,736. The other way we could have done it is we could have said, look, this is a permutation. We have 33 choices for the first person, times 32 for the second, times 31 for the third. And since order doesn't matter, we just leave this alone. And that's going to give us the same number. 33 times 32 times 31 is 32,736. That's it for 6C. Have a good day.